Hey guys, I hope you all are doing great. I'm so excited to start another series on N10-008 Network Plus from CompTIA. This is the latest version. My name is Sheikh Rashid Javed. I am a Microsoft certified trainer, certified EC Council instructor, and certified cybercrime intervention officer. Almost 20 plus global certifications. I work as a cybersecurity trainer. My area of interest is network security and cloud. I travel to a lot of places. I talk to a lot of government organizations, a lot of private organizations, schools and colleges, where I discuss on network security and cloud related concepts and global certifications. So let's get started here with the latest version from CompTIA N10-008. I have done IT fundamentals, I have done security plus SY0, 501, 601 and network plus from CompTIA. So let me share my screen here. Getting started here with N10-008. So there's a note on my screen, and this video is for those who are planning to write your N10-008 exam. It just gives an overview to important points. Since I did this exam yesterday, I was able to pass it, so I'm going to cover all the important points which we need to remember to pass this exam. I highly recommend to attend CompTIA's official training for N10-008, and you need to go through a CompTIA study guide with approx 500 plus pages. You need to go through some official labs from CompTIA, which are almost 32 in number, and also you need to go through practice questions online. So to tell you frankly, I have spent a lot of time in networking, but I found this exam a little difficult since I was having a little bit of experience. So what I did is I just have gone through the official book from CompTIA, and then I did all the labs, and after that I did some practice questions, and still I found it a little difficult to pass this exam with the way they ask those questions. So my suggestion would be to go through the book not only once but twice, maybe 3 times. Go through the lab, spend proper time, and I'm going to show you at the end what are the labs being covered. So what I did is I just come up with some important points. If you are planning for the exam, I would say after attending the training, after going through the book, after doing a lab, please watch this video, so that it's going to be like a refresher guide, or it's going to give an overview what are the important points you need to remember to pass your exam. So I did this exam yesterday on 15th October, and today is the 16th. I am recording the video since all those questions, all those concepts are in my mind. So I'm going to cover all the important points which we need to go through. So I highly recommend to go through all that what I have shown in the video, CompTIA official training, the study guide, the official labs, to be able to pass this exam. To tell you guys frankly, I found it a little bit difficult since I've spent a lot of time with networking. I was able to pass it, but to tell you frankly, I have just gone through the practice questions. I was not able to see any of those questions in the exam. So what I did is I will show that technique also which I used in the exam. So I did this exam. Now I'm certified with N10-008, the latest version. Alright, so there are 20 modules which we need to cover in Network Plus. Since there are two exams when it comes to networking, one is a Cisco and one is from Network Plus, CCNA, right? So I am also a part of Networking Academy, Cisco Networking Academy, and since if I compare both of them, there's a lot of demand for both CCNA as well as Network Plus. But if you want to make your career in Cisco, you want to go for CCNA, CCNP, CCIE, choose that path. But if you want to understand networking concepts, maybe you are planning for some other certifications like cloud, Hadoop, big data, or maybe security plus, CEH and all, incident handling, forensic investigation. And if you want to understand networking concepts, go for Network Plus from CompTIA. Since I work as a trainer for both CompTIA, for EC Council, for I was a part of Cisco also. So I am not saying that I'm not saying this is what I would refer, but based on what is your requirement, right? So what is your need? Based on that, you can choose the certification. So if you want to make your career in Cisco, go for CCNA. If you want to understand those networking concepts because you are planning for maybe Security Plus or Cloud Plus, then go for Network Plus. You're going to understand all those concepts here. So there are 20 modules. The first one is comparing OSI model network functions. Second is on deploying Ethernet cabling, then deploy Ethernet switching, troubleshoot Ethernet networks. Then we'll understand on IPv4 addressing. We'll try to understand what's the difference between IPv4 and IPv6. Then we'll see troubleshooting and configuring routers. Then we'll see about network topologies. We'll see about transport layer protocols. We'll see about network services. Then on module 11 is about network applications, network availability. Then we'll see some security concepts. We'll see troubleshoot and secure networks. We'll see wireless networks. We'll see WAN links and remote access methods. We'll see organizational and physical security concepts. We'll see about disaster recovery and high availability. We'll see about network hardening, and at last we'll see about cloud. Since I am a certified ethical hacker, I am also into disaster recovery. I'm certified disaster recovery professional. I am also certified with cloud, so it will be easy for me to kind of take you guys through this course. So let's see what are the important points. Since I am not going to cover everything, but I'm going to cover what you need to remember in exam for each module. So exam objectives, if we see lesson 1 and 4, it is based on physical and data link layers, and 5 to 8 is based on the network layer of OSI model. 9 till 12 is based on the upper layers. So if you see the OSI model, there are 7 layers: physical, data, network, transport, session, presentation, and application. Wireless, then we'll see security concepts, wireless and WAN, lesson 13-16, and 17-20 is based on site security and cloud data center concepts. The CompTIA Network Plus certification exam will verify the successful candidate has the knowledge and skills required to establish network connectivity by deploying wired and wireless devices, understand and maintain network documentation, understand the purpose of network services, understand basic data center, cloud, and virtual networking concepts, monitor network activity, identify performance and availability issues, implement network hardening techniques, manage, configure, and troubleshoot network infrastructure. So I've taken all that from CompTIA, whatever they want you to understand. So all the content is from the official book from CompTIA. Since I would recommend to go through the book, which is approx 500 or maybe 500 plus 550 or 600 pages, but if you see the actual content, it is 500 pages. Rest you have those terms, glossary, and all that. I would say like 550 pages you need to go through. I recommend, if you want to pass this exam, just buy your official handbook from CompTIA. Since I come up with only important points, and these are from CompTIA. So on course completion, you'll be able to deploy and troubleshoot Ethernet networks, support IPv4 and IPv6 networks, configure and troubleshoot routers, support network services and applications, ensure network security and availability, deploy and troubleshoot wireless networks, support WAN links and remote access methods, support organizational procedures and site security controls, summarize cloud and data center architecture. Based on those 20 modules, you are going to understand these techniques. Alright, so let's see what are the important points we need to remember when it comes to OSI model. So there are 7 layers. We need to remember them: physical, data, network, transport, session, presentation, application. You got a lot of ways to remember. Please do not throw sausage pizza away, or please do not take salesperson's advice. There are a lot of ways to remember, because when I first started learning on OSI model, it was very difficult to remember these layers. But after that, it's easy for me right now, because I've spent a lot of time trying to understand this model. Like you just need to understand, because they'll be asking any question like layer 2. So this is layer 2, layer 3, layer 4, layer 5, right? Layer 6, layer 7, and layer 1. So they will ask a question based on that layer, and we need to understand what are the devices which work at each layer. For example, switch works here, router works here. You have some advanced devices, gateways and all, which work here. Like hub works here, repeater and all that works here. So I'm not going in detail, but maybe I have another slide where we'll understand OSM model. But OSM model divides network technologies between 7 functional layers. A network is two or more computer systems that are linked by a transmission medium and share one or more protocols that enable them to exchange data. So this is the exact precise definition of a network. At the physical layer, a segment is where all the nodes share access to the same media. Sometimes we say segment. So segment is where all the nodes share access to the same media. That's what we call segments. Please remember these keywords. Nodes that send or receive information are known as end system or host nodes. They'll ask a question based on that. So we need to remember. That's what I've seen in the exam. We need to remember these important points. And one of the technique which I used in this exam is I tried to remove wrong answers. So I was not exactly 100% sure what's the correct answer, but what I did is I tried to remove wrong answers. So when I saw question 1, it was very difficult for me because it was something new. I just gone through the book. I've just did, so it was some new concept. Now time was limited, so a lot of things are running in your mind, like limited time, new question, how to answer it properly. So a lot of things were running in my mind. What I did is I just went through, I think, I guess I saw like 70 or 80 questions. I'm not exactly sure, like 70 I guess, because I was a little bit nervous. Even after doing a lot of practice, I was a little bit nervous. Frankly, telling you frankly, this is the exam where I find it a little difficult. And another one was SY0501. That time also I become a little bit nervous because the kind of questions they have been asking in security plus 501 was little kind of a difficult one for me at that time. I was not much prepared. Same goes for network plus. I did I did a practice. I was not expecting it could be that much hard. So I will say, like, spend a lot of time and proper planning, you can easily pass it. SY0601 was easy for me. I did, like, that very quick because I had a lot of experience after that. But network plus was a little difficult. So what I did is I just in the first 1 hour I attempt all the questions and I kept them on review. And then there was 1 hour, like 40 or 50 minutes I did it, and then I was left with 1 hour or maybe 50 minutes. And what I did is I started those questions which were on review, and what I did is I just tried to choose what is the best answer. So for a few questions like 20 or 30, I was sure that this is the answer. I just attempted that. But for other questions, I was not sure, if 100% sure. So I wanted to choose the best one. So what I did is on the second go, what I did is I just tried to attempt those questions with what I feel was the best answer. So I removed those wrong answers, and what I feel was the best answer. That technique worked for me yesterday in yesterday's exam. You have a lot of ways. You have a lot of techniques. Knowledge is important. Plus what technique you'll be using to pass this exam, that's also very important. So a node that provides only a forwarding function is known as intermediate node. This is also what we call infrastructure node. Sometimes they ask a question based on infrastructure node, so that's what you need to remember. Please remember these important points with respect to OSM model. Now this is OSM model. I've just covered it. I in fact made a video on this, but let me cover it very quick. How we use OSM model, because in the schools and college when they teach OSM model we don't remember, but I try to spend a lot of time trying to understand the OSM model, what's happening here. So if you see my computer, I'll just give a quick overview. If you see my computer has a kind of an IP address. My computer has a subnet mask. It has a default gateway 2.1. It is also generating 2 port numbers, but the port range starts from 50,000. Like, if you see the port numbers, we have starting from 0 till 10 to 0 till 65535. 0 till 1023 is well known. 1024 till 49151 is registered. 49152 till 65535 is your dynamic ports. But some of the systems, they might not generate the port in this range because a lot of reasons, but normally dynamic ports are something which is generated by my system. It starts with 49151. So I assume the port number is 50,000. Maybe I'm just opening 2 applications. Maybe this is my Google, I'm opening a Google, and this is my Yahoo, and let's assume this is the Google server. I'll write in short, to make it quick. So what I'm doing is I'm trying to open Google. I'm trying to tell my computer, please get me the index page of Google. Now my computer will say, Sheikh, I don't know what you're talking about. Okay, it will go to the DNS. Hey, Mr. DNS, Sheikh is asking for Google. Do you have the IP of Google? So this will say DNS, yes, I know the IP, that is 3.80, right? So that is 3.80. DNS has the record of all those sites. Now what happens here? Now my computer will understand, okay, Sheikh's IP is 2.3 and Sheikh is asking me to get a Google which is something like 172.160.9.3. Okay, now it will see, okay, Sheikh's IP is this, Google's IP is this. Are they in the same network or a different network? Now subnet mask is going to help this computer to make the decision. Now here we know it is in a different network. It's going to use a subnet mask to understand if the destination computer is in a SAM network, give it to a switch. If it's in a different network, give to a router, which is a default gateway. And my computer already has the default gateway IP because maybe DNS has already given it. Maybe I'm using dynamic IP using DHCP. So DHCP has already given it the default gateway. Sorry, not DNS, default gateway. Now what my computer will do, it will say, okay, I need to give it to the default gateway. So what it will do, it will do a ARP. It says, okay, I know the default gateway IP is 2.1. So whoever is 2.1 in this network, there might be a lot of computers. Whoever is 2. My computer is going to say, whoever is 2.1 in this network, please give me a MAC address. Now switch will say yes, sorry, router will say yes, this is me, my MAC address is MD. Okay, now what my computer will do, my computer is going to create a frame. It cannot send a packet because what happens here, if you see the OSM model, physical data network transport session presentation application, at the data link layer we have a frame has a MAC address. At the network layer we have a packet which has an IP address. At the transport layer we have a segment which has an port address. So 3 addresses are important. That's where spoofing can happen. Now my computer will create a frame because it has to go through a switch. Switch will understand only MAC address and router will understand only IP address. That's very important because MAC switch works at the data link layer. Now what it will do, it will just create a frame. The source IP is MAC is MA, destination is MD because it has to go to the router. Now what router will do, router doesn't understand MAC address. It will just open the MAC, it will open the frame. The outer one is what we call frame. So it's just going to open the frame. In the frame it is just trying to check the IP. Oh, it is coming from Sheikh 2.3 and it goes to 9.3. Okay, it goes to Google. I have written it short 2.3 9.3 to make it simple. Now it will say, oh, it's coming from Sheikh, it goes to Google. Do I have any other way? Is it going this way? Is it going this way? Okay, this is the way. Now what router will do, it will create another frame. What will be the source now? ME. And what will be the destination? MF. Okay, now this frame goes to, I've just kind of made it simple, otherwise a lot of things happen at the back end. So I just assume there's no router in between. No, that's to make it a little bit simple. Now this is a server, this is a PC, it's going to open, it will say, oh, I got a frame, okay, it's coming from this guy. So with the help of frame, it will not understand where from this guy is coming. It will think router has sent it. So with the frame you cannot understand where from this guy is coming, but it's going to open a packet. It's saying, oh, it's coming from Sheikh 2.3, it goes to 9.3. okay, it is for me, it is coming from Sheikh. So this is actually the packet makes it sure that your data goes from source PC to destination PC with the help of IP address. That's why we say IP is important, MAC is important. That's why we say if you have a MAC, why you need IP. So it's going to solve a lot of questions which you have in your mind. But I have already made a very long video, but this is just a short overview. So it's going to open it. Okay, it will show, oh, there's a segment. Okay, it has 50K and it is going for 80K. So it is going for 80K. Okay, maybe there is some other service running on this. Maybe this is a your email service. This is your HTTP service. So with the help of port number, it will understand it is coming to this service, right? So with the help of IP, it goes to the right PC. With the help of port, it goes to the right process on that PC. That is process to process communication. That is what port does. Now why port is important? Now it's going to open it, it's going to send a reply. Now when a reply comes, everything is going to happen in the reverse. The source frame will be, maybe here is going to be MF, destination is going to ME. It's going to open it. It'll, oh, this is going for Sheikh, and it is just going to attach MD as a source. For the destination, it will again do ARP. I have a message for 2.1. Whoever is 2.1, please send me a MAC. Sheikh will say, hey, this is for me. Take my MAC. Sometimes some people do spoofing. They pretend to be Sheikh. They send a MAC address, get a copy. Now this comes to my PC and I'm going to open it. Okay, I'll say, oh, it is a reply coming from Google. It's coming from 9.3. It's coming to 2.1. I'm going to open it because it's for me. Like the way you give a letter, please give it to him. And if it is not for you, you are just going to pass it to that guy. There's a trust. Unless and until you are working in promiscuous mode or using something illegal, port mirroring and all. Now Sheikh is going to open it. Okay, Sheikh will see, oh, this is a message for this process. So that's why this port is important. It is for my PC. On my PC, it is for this process. That's why we need those port numbers. Source port and destination port, from which process to which process. So that is where OSM model is very important. So these layers help in communication. Physical layer is going to with the way you connect them. Session is how you maintain the session, how you terminate the session, how you connect the session with the session ID. Presentation will present data in a standard format. Application is the way we interact with our PCs. So this is how OSM model works. Now if you understand this, it will be easy for you to troubleshoot. If there's any problem with your network, you'll start, okay, it's a MAC address, no. Is it IP address? No. Is it a port address? No. Is it a browser? So you're just going to do a logical troubleshooting. Bottom up or bottom to down, or bottom to up or up to down, whatever technique you say. Okay. So now very important. What are the devices and why they operate? So please remember, they ask a question in exam every time. Like, physical layer, trans receiver, repeater, hub, media converter and modem, they work at physical layer. This is from a book. You might see some questions where there's some different answers, like you might see modem working at a data link also. Just go through this one because this is from an official book, so they expect an answer which is from official content. Data link, you have NIC, you have bridge, you have switch, and you have wireless access point. So I know you understand switch and bridge, but remember these two devices also. At the network layer, you have a router, you also have a firewall. Now I'm not talking about basic firewall because firewalls are also of different types. In the book they say a firewall unless and until they mention what kind of firewall. If it's a packet layer firewall, it works at network. If it's a a session layer firewall, if it's an application layer firewall, so firewalls have different types. Is it stateful, is it stateless? So accordingly you have to check what firewall they are talking about. But if it's a normal firewall, go with network, because normally they are talking about packet layer firewall. Transport, multi-layer switches, advanced firewalls, IDS, like these are some other advanced firewalls which work here. But if you have any confusion, they will just mention what kind of firewall, then it will be easy for you to go through that, what layer. But please remember, now SOHO, this is small office home office router. So what happened is, like, it was very difficult for a small business to buy a modem, modulator, demodulator, because signals are coming from those wires. Those are analog signals. They go to a computer, they need to be converted. So you need a modem, you need a router to connect two different networks, you need a switch, you need an access point to connect wireless devices, you need firewalls, you need all those things. So what they did is they just made a single device which is going to do all of those things. So it has a button to turn it on and off. It has a reset button, it has a power button, there's an Ethernet cable which is coming from your ISP, internet service provider, and then you can connect your 4 computers here, and then you also have an access point where you can connect wireless devices. This is what we call SOHO, small office home office. So a category of LAN with a small number of computing hosts that typically rely on a single integrated appliance for local or internet connectivity. SOHO router is also known as CPE, customer premises equipment. You might have heard that if you work with Verizon, AT&T, because I started my job with AT&T. In troubleshooting, my first job like 10-15 years back. So we used to troubleshoot those devices here. So there's a CPE, customer premises equipment. There's a cloud premises equipment, or service provider premises equipment also. CPE is connected through its modem and WAN to the local loop. The point at which telco's cabling enters the customer premises is known as demarcation point, or demarc. So that point is what we call demarc, where there's a kind of responsibility. So if it is up to the demarc, it is your responsibility. If it's just outside demarc, any problem, your cloud or your ISP is going to fix it. IANA is your Internet Assigned Numbers Authority. it manages allocation of IP addresses and maintenance of the top level domain space. Like, top level, you might have seen top level domains. We have like .com, .net, or before that we have the root, which are at the very top. There are 13 root servers, we need to remember. But what IANA does, it manages the allocation of IP addresses, the maintenance of the top level domains. This is run by ICANN. IANA also allocates addresses to regional internet registries, RIR, right? AFRINIC, LACNIC, and all that. IETF is Internet Engineering Task Force. It focuses on solutions to internet problems and the adoption of new standards published as RFC, request for commitment, right? Those documents. So you cannot update them, but you just come up with a new one. If there's any change, you come with a new version. So that's what we need to remember in module 1. So module 2 is deploying Ethernet cabling. So please make it sure that we remember these points here. Electromagnetic radiation means transmitting signals as electric current, infrared light, or radio waves. So if it talks about 100 base TX, this is what we also call fast Ethernet. It uses Cat5 twisted pair copper. The length approx 100 meters. After that we need those repeaters. So 10 base T specifies that a node should transmit electrical pulse when it is not transmitting data to confirm viability of a link, which is what we call a fast link pulse. It is a 16-bit, right? So please remember this term. This is what we call a fast link pulse. It is 16 bits. So copper wire thickness is measured using American wire gauge. That's what we call a AWG. So please bear with my pronunciation. I might not pronounce these words correctly because of different language which I speak, but I will try to make it neutral. If you feel you're not able to understand, please don't mind, because I am not a native speaker. So increasing AWG represents a thin wire. Please remember this. Increasing AWG is going to represent a thin wire. For example, solid wire uses a thickness of this, while a stranded cable used for patch cord is often 26 AWG. Very important. Increasing AWG, so they might give you a question like, is this good or is this good, or which cable, like so we need to remember increasing AWG represents thinner wire. Solid cable uses thicker wire, which is this, while stranded cable used for patch cord is this. Attenuation of a stranded wire is higher than solid wire. So these important points. Now they design a question based on these keywords. That's why I've just included them. So it'll be easy. Whatever questions they are asking, if you know those terms, it'll be easy to pass it. All right. So different types of cables which we have. Screen cable has one thin outer foil shielded around all pairs. That's also what we call foil twisted pair, FTP. There's also some other cable which is fully shielded cable. Fully shielded cable having a braided outer screen and foil shaded pair. This is also what we call shielded foil twisted pair, or SFTP. So two cables are there, right? Screen and fully shielded cable. RJ45 is that connector which we connect an Ethernet cable to your laptop or to your PC. So this is also what we call 8P8C, Ethernet twisted pair cabling. This is used as a tip by using those crimping and all that. We used to do that long back, crimping and all. RJ11 is a smaller one. This is for telephone systems. That's also what we call 6P2C. Now if they ask a question based on these points, please remember that's also what we call 8P8C, 8 pin 8 contact, I guess. This is 6 pin 2 contact. Data cable that is plenum rated under the US NEC is also what we mark them with CMP or MMP, right? P at the end. And these are two different types of cabling. Otherwise, you have those colors, why there's a color, why they are twisted. So there's a reason for everything. But this is your 568A. So if you have a white green at pin 1 and green at pin 2, this is your 568A and this is your B. So please remember, B has orange at the start and this has green at the start. So if it is green here, it is being replaced by orange here. So the only thing which I would say to remember is this has green, A has green starting, and standard B has orange at the starting end. And the thing, RG6 is 18 AWG with 75 ohm, typically used as a drop cable for cable TV and broadband cable modems. And there was a question based on what's the connector which we use for fiber optic. So F-type connector, we need to remember this is for your RG6. But there are two types of fibers. Like one is a single mode. It has a small core, long wavelength, near infrared signal. We use laser. Speed goes up to 100 GB, and cable runs for many kilometers. There was a question based on one logic and the question related to this concept. OS1 is for indoor use and OS2 for outdoor. There are other two versions, two types here. There's also a multi-mode fiber. It has a large core, shorter wavelength, less expensive, doesn't support high speed or long distance. It is suitable for LANs. Please remember those keywords. There are two versions for multi-mode. One is OM1, OM2 for applications using up to 1 Gbps and using LED, and there's 2 and 3 which is for VCSEL and LOMF. They didn't ask this time, but we need to remember these points about on this concept. Okay, there was a question. Now, they gave a lot of connectors, and there was, I think, SC or ST. There was one connector they were asking, for which cable you can use it. So please remember those connectors. There's a question on this. So straight tip, this is early your bayonet, or what you call here, style connector, and uses push and twist locking. Was used mostly for multimedia networks, or sorry, multimode networks. There's also a subscribe connector. This also is a push-pull design. Simple insertion and removal, can be used for single or multimode, commonly used for gigabit Ethernet. There's also LC. It has a small form factor. This is your local connector. It has a tab push-pull, small to SC, higher port density, or it has gigabit Ethernet and 10 or 40 GB. There's also MTRJ, mechanical transfer register jack, small form factor, duplex snap-in design, used for multi-port network. So please remember those important terms. And there was a question on what connector you can use for fiber. So there was a damage in the fiber, and they have to replace. So which connector they'll be using. And see, here we have two types of blocks. One's a 66 block. This is an old style distribution frame which is used to terminate telephone cabling and legacy data applications. It has 50 rows of 4 IDC terminals. 25 pair cable from access provider is terminated on one side. There's also 110 block, which is the new one developed by AT&T, supporting 100 megahertz, arranged horizontally. No, this is vertically, this is arranged horizontally. Better density, more space for labeling connectors. It is color coded, and distribution frame works at the physical layer. Very important point. Okay, so this is it about module 2. Now let's see what we need to remember on module 3. So module 3, media converter works at a physical layer. Hub is also what we call multiport repeater. It also works at a physical layer. Bridge is a layer 2 device. Each switch port is in a separate collision domain. Switches are going to establish a point-to-point link between any two network nodes, referred to as microsegmentation. So this also, please remember, this is an Ethernet frame. So these are the parts. There's a preamble, there's SFP, destination MAC, source MAC, Ethernet type payload, and FCS. Preamble is 8 byte of alternate ones and zeros. Preamble and SFD are used for clock synchronization. It's a part of CSMACD, carrier sense multiple access collision detection, to identify collisions early. SFD being 2 consecutive ones, like so. These are 2 ones. Error check is a 4 byte. MAC, this is also what we call EUI address. It's a 48 bit, 6 byte. This is also what we call, now they might be asking questions based on what's burn-in address. So we need to remember MAC address is also known as burn-in address, universal address, physical address. So the first 3 bytes is your OUI, and the last 3 bytes is your serial number. A locally administered address is defined by changing the UL bit from 0 to 1. Universal or local, right? IG bit of a MAC determines whether frame is addressed to an individual or group. So 0 is for individual and 1 is for group. IEEE 802.3. So this is very important. Defines 2-byte field to specify size of payload. Payload should be between 46 or 1500. This is the limitation for Ethernet frame. MTU is your maximum transmission unit, upper limit of a payload. To comply with CSMA CD, minimum length of a frame should be 64 bytes. Now this is the payload, right? And this is the frame. But there are some jumbo frames, they have much larger MTU, I guess 9000. We will discuss that. But those are what we call jumbo frames. They're used for fast Ethernet and all. There are some sniffers which are going to read some packets. So these are the different ways. You can use a SPAN, which is switch port analyzer. This is what we also call a mirror port. Sensor is attached to a specially configured port. It's not now the important. It is not completely reliable because frames with errors will not be mirrored and frame may be dropped in a heavy payload with SPAN. That's why we should go for tap, passive or active. Passive tap is a box with ports for incoming and outgoing cable. It also has an optical splitter. Mirror port is going to receive every frame, whether it is corrupted, malformed. It is not affected by load the way this is affected. There's also an active tap. This is a power device. It does signal regeneration. Gigabit over copper is too complex for passive tap. Some fibers may be affected by splitter in passive tap, right? So that's why we should go for active tap, because we use a splitter, so some fibers may be affected by splitter. That's why you should go for active tap. So please remember what's the difference. There's also similar to this Wireshark, there's a TCP dump. It's a command line packet capture for Linux. Wireshark is your open source graphical packet capture and analysis utility. T-Shark is your command line version of Wireshark. Now there was a question on this concept. On a switch, an interface has a line status up if a host is connected through a good cable. No, sorry, not this other one. But remember this, and the protocol status up if the Ethernet link is established. Administratively down indicates that the port has been purposely disabled. Under 100 base T, an end system uses MDI to transmit on pin 1 and 2 and receive on pin 3 and 6. This is what we call uplink port. But intermediate systems like switch, they use MDIX, which is going to do the reverse. So here it's going to transmit on pin 1 and 2, here it's going to receive on pin 1 and 2 and send 3 and 6. So that means you need to connect one end should be MDI, other end should be MDX. So then you can use a straight cable. But if you want a cross cable, then both the devices could be doing same thing. Because when you do a straight cable, one is going to send, other is going to receive. When you do a cross, both are sending at the same time. If you use a straight cable, this is also sending, this is also sending. There will be a collision. So one is your straight, other should be, sorry, the cable should be cross. One is going to send, other should be receiving it, right? So port security configuration validates the MAC address of an end system that connect to a switch port to make things secure. Like if you are trying to connect your PC to a switch, it is going to kind of maybe shut it down, or it will not allow you, depending on how many PCs you have configured. There's also port aggregation, combining two or more separate cable links into a single logical channel. This is also what we call NIC teaming. There was a question on this. This is also bonding implemented by a link aggregation control protocol. This protocol detects configuration errors, recover from failure of any one physical link. Jumbo frame supports payload of up to 9000. MTU in show interface output will indicate if jumbo frame are accepted. And there was a question on PoE also, supplying power from switch port over ordinary cable to connected power device. So please remember 802.3AF has a power, this much power, 802.380 has this much power, and this has this much power. Please remember those terms. I don't remember exactly, but there was a question, not the exact question, because I will not be saying the exact question, but it will be again, I might be violating their policies and all that. So what I was saying is just remember those concepts, and there'll be a short question. There was a question on PoE. I'm not telling the exact question, but just remember these important points. Now, module 4, lesson 4 is troubleshooting Ethernet networks. We need to remember these kind of steps in a sequence, and they were like two three based on those concept. So first thing is you identify a problem as per CompTIA. Now you have your own approach, but CompTIA says first identify the problem, gather information, check what is the scope of the problem, identify what are the symptoms of the problem, then duplicate the problem. Then you got to question your users and tell them if anything has changed, and you got to approach multiple problems. So there was a question based on the logic. If a lot of these things happen, you are trying to troubleshoot, so what should you do first logically? Now you can do a lot of things first. You can ask, okay, restart your computer, do this, do that. For example, your customer says, I'm not able to go online. Okay, restart your computer. Now what is the first logical step they expect? Maybe restarting is going to take a lot of time, so maybe you can ask him, please check if your cable is disconnected. That makes more sense. So that's what they expect. Now, a lot of answers might be correct, but go for a logical answer. Establish a theory of probable cause. You can have that top-down or bottom-up approach OSI model, which I was discussing. Or you can divide and conquer, starting with any module like model 3, and just start troubleshooting the IP address and then go up or down, up or down. That's your divide and conquer. Test the theory of determined cause. If you cannot prove your cause, then you develop a new theory, or you can escalate because you have a fixed time to work on a problem. Then establish a plan of action. So you are going to either repair that, you are going to replace it, or you are simply going to ignore it. And implement a solution. Maybe resetting a system or reverting to known good configuration, or escalate can also be implementing a solution. And then after implementing a solution, verify full system functionality and implement preventive measures. Very important. Eliminate any factor that may cause problem to reoccur. For example, if a customer is using pen drive which has infected his system, next time you ask him, please scan your pen drive, or please do not use your pen drive in your system, or any other solution. Document findings, actions and outcome. Others can rely on it as a proof of troubleshooting activities. So please remember all those techniques in a sequence. You are going to solve 2 or 3 questions. The number of symbols that can be transmitted per second is called baud rate, measured in hertz. Bandwidth is amount of information that can be transmitted, which is measured in bps. Throughput is average data transfer rate, which is achieved over a period excluding encoding schemes, errors and other loss. Throughput is measured at network layer or transport layer, but goodput is used to measure average data transfer rate at application layer, taking into effect packet loss also. Attenuation is loss of signal strength, which is expressed in dB. Noise is anything that gets transmitted within or close to the channel that is not the intended signal, right? So please remember those important points. You also have a loopback adapter. So this is also what we call loopback plug. So what do you do in the loopback? Pin 1 is connected to 3 and 2 is connected to 6, because 1 does transmission and 2 does transmission. So transmission is going to receive, transmit, this is going to receive, to test your bad ports and network access. So please remember the light status. If it's a solid green, link is connected, no traffic on your switch. If it's flickering green, it is okay, it is normal. If it is no light, it is not working, it is disconnected. Blinking amber, fault is detected, duplex mismatch or spanning tree blocking. If it is solid amber, port is disabled. So please remember, because what do you do when you work troubleshooting networks with the help of those light status? We used to do it. Okay, what is the color of the light? What is the color of this light? Okay, that is a problem. For example, I remember we used to tell him, what's the DSL light? So, oh, it's red. We'll see, oh, that could be a problem with your cable. So let me see if I can run some other test. Also, I will send a technician to your home. If it is a authentication issues, I'll ask him, okay, reset your password based on that light. If a host is set to fixed configuration and the switch is set to auto negotiate, so please remember this. On this logic, there was a question. If a host is set to fixed configuration and switch is set to auto negotiate, switch will default to 10 Mbps half duplex, because host will not negotiate with it. Now if host is manually configured to 100 Mbps, link will fail. So what do you do here? Again, switch has a default 10 Mbps with half. So sorry, host is set to fix and switch is set to auto. So what will happen? Switch is going to go to default 10 Mbps with half duplex because host will not negotiate with it. Now if you try to manually configure the host with 100 Mbps, link is going to fail. So what do you do? Set both to auto negotiate, which is going to solve the problem. A speed mismatch will cause a link to fail. Very important point. A speed mismatch will cause a link to fail, while a duplex mismatch will slow down the link, cause high packet loss or late collision. On this concept I saw a question, so please remember, if there's a speed mismatch, link will fail. If it's a duplex mismatch, link will be down, causing high packet loss or late collision. So they ask a question, if there's a late collision or there's a packet loss, what could be the problem? And there was a question on this also. They were asking you to choose a device, so answer was TDR because that was for an optical cable. So it's a time domain reflector, measure length of cable run, can locate open and short circuits, any kind of sharp bands, or what they call kinks, or I'm not sure how to pronounce it, kinks, or maybe something, I'm not sure how to pronounce kinks or sharp bands, and other imperfection that could affect the performance. Multimeter can check the physical connectivity for testing electrical circuits. It can test connectivity, short, integrity of a terminator. 100 ohm resistance across a UTP is okay. If you get a 100 ohm resistance, that's okay. But if you get an infinity, that means there's a break. Wire map tester is going to identify continuity, open, short, incorrect pinout, termination, and a mismatch standard. Split pair is when both the ends of a single wire in one pair are wired to terminals belonging to a different pair detected by wire map tester, which also detects excessive crosstalk. I'm talking about the wire map tester. Tune generator traces the cable, fox or hound, or tune probe. There was a question, they were asking a lot of connectors, but I just choose this one, what is that? TDR. There was OTDR, I think. Yeah, TDR was there. So I just choose this because that was a fiber optic cable. And there was OTDR, I guess. Yeah. Insertion loss is measured in dB, is the ratio of received voltage to the original voltage. 20 dB insertion loss is better than 20 dB. So this is an example. Interference from a nearby data cable is also known as alien crosstalk. There is also RFI, which is radio frequency interference. It's an EMI that occurs in frequencies used for radio transmission. Different types of crosstalks. One is the next. This is what we call near end crosstalk at transmitter end, caused by excessive untwisting. Very important point. ACRN, this is attenuation to crosstalk ratio. Near end, this is a difference between insertion loss and next, equal to, this is similar to SNR, which we see, signal to noise ratio. Results close to 0 indicate higher error rate. ACRF is attenuation to crosstalk ratio. Far end measured on received pair. Difference between insertion loss and FAXT gives you ACRF. Power sum, gigabit and 10 GB use all four pairs. Power sum crosstalk calculations confirm that a cable is suitable for this type of application. They are measured by energizing 3 or 4 pairs in turn. So please remember those important points in crosstalks, with types of crosstalk. Now there are different types of cables which we need to remember. Straight throw cable terminated with either this standard or this at both the ends. This is used for uplink MDI to MDIX. But crossover cable is terminated with this on one end and this on other end. So two standards on two different ends. Used to connect host to switch or switch to switch. You can say similar devices. All gigabit Ethernet ports support auto MDX. So what is auto MDX? Now you don't need to worry if you are choosing a wrong cable. It's going to automatically fix it. Rollover or console cable is used to connect a PC to a command line terminal of a switch or a router. Aux port is used to connect to router or dial-up modem, but console port uses serial link. So please remember these different types of cables. Now let's go lesson 5. The maximum theoretical size of a packet is this. IPv4 is your 32 bits, 4 groups of 8 bits each. This is called dotted decimal notation because we write it like 192.168.2.3. Like these are 4 groups. Each is 8 bits. This is dotted decimal. Network mask is your 32 bit used to distinguish a network ID and host ID. Subnet addressing has network ID. subnet ID and host ID. So this is your, please remember on IPv4 addresses, so the classes, the range. Class A has a range starts with 0 till 127. In some books you can see starting from 1 because 0 we don't use, and 1 till 126 because 127 is used for loop back. But just remember it goes from 0 till 127. Class B 128 191, Class C 192 223, Class D for multicasting 224 till 239, Class E 240 till 255. Now what's the benefit? I give any class like if I give an example like 35.4.9.1. So which class? Just check. 35 is in this range, it's a class A. 291.4.3.2. Okay, I need to check. 291 is in this range, right? So it's a class C. So that's how we remember. And you need to remember every class has a formula. So this has network host host host. This has network.network.host.host, network.network.host.host. Now I need to remember this. So this has less networks, this has more host. If you need more host, go for class A. This has more network, and each network there is like 8 bit is for like for class A, 8 bits are for network and 24 888 for the host. This has 1616. This has 24 888 for the network and 8 for the host. Now please remember private address range, anything which starts with 10 is a private address for class A. So for class B it's 172.16. anything. So why I mention this anything could be starting from 0 till 255. So this number I just made it a little bit simple. This anything means starting from 0 till 255. So if you see 10 dot anything, it is a private address for class A. Rest all are public. If you see 172 till 16 and goes from 170 to 31, so that's why they'll be asking some questions based on this concept. I'll give an example. But for class C it's easy. 192.168. anything is a private for class C. So this is also easy. 10 dot anything is a private, 192.168 dot anything is a private. But for class B there's a confusion. I'll say, for example, I give an IP 172.3.4.1. now this is public. Why? Because you have to check the first one is 172 and the second one should be between 116 till 31. Okay, so if I check the second one, this is 3. This is not between 16 or 31. So what is between 16 and 31? For example, 172.17 dot anything, like, no, this is a private because it falls between this range. So please check those questions on class B. They will ask questions based on class B because that's why there's a confusion. Now what are the questions? Which class? Is it class A, B or C? Are they in a SAM network or different network? Is it private or public? Now how to remember SAM or different network? Because if I give an example 192.4.3.2 and let's go with another class like 192.4.1.2, are they in the same network or different network? So what you need to do for this is just draw the formula which I have mentioned here. This first you need to check, is it class A, B or C? 192 is class C. So what's the formula for class C? network.network.network.host. So that means for these two IP to be in the same network, these three should match. Okay, let's see if they match. It's going to help a lot. Now does this match 192 to 192? Yes. Does this match? Yes. Does the third match? It is 3, this is 1. Okay, no, this doesn't match, so they are not in same network. So first three should match. Same goes for class B. For example, if I give a class B IP, so class B, like 171.3.9.2, 171.3.0.1. okay, now I'll draw a formula. Now first I need to check which class. Okay, it's class B. Let's draw a formula for class B. Network, host. Okay, so 2 should match. Okay, in this case 2 should match. In class C, 3 should match. In class A, only 1 should match. This is class B. Does it match? Yes. Does it match? Yes. It is. They are in same network. You don't need to worry about these because these are host bits. For two IPs to be in the same network, network bit should match, in short. Subnetting, I just gave an example here. I have seen a lot of ways to do subnetting, but this is a simple technique. If you understand that, you will solve 3 questions, 2 or 3 for subnetting. They ask 2 or 3 in every exam related to subnetting. In Cisco you can find a lot of questions, CCNA. So I've given an example class C, right? So this is 192.168.3.5 and the subnet mask is 255.255.255.0. It's a default subnet mask. Now what I need to do is I just need to convert this subnet mask into ones. So if I see 255, that means 111. I can represent that 255 in binary like this. Now how to convert that, I have just made a video. I'm not going that deep in this, how to convert decimal to video, but how to convert decimal to binary, binary to decimal, it's very easy. But 255 is equivalent to this, 255, 255 and 0. Now what I need to do, I'm doing subnetting on this. I'm just converting two zeros. Subnetting is converting zeros to ones. So what I'm doing is I'm converting two zeros. So these are my network bits. So I'll just represent network bit is 2 because I'm converting 2. Now how many host bits I am left? 1, 2, 3, 4, 5, 6. Because total is 8. In this octet I have only 8 bits. So I'm just converting. So this was the first octet, 8 bits. What I did, I just convert zeros into ones, that is subnetting. So I call them network bit is 2 and host bit is 6 because 6 plus 2 total is 8. I'm working on this octet in class C. Now how to calculate number of networks is 2 to the power network bit. So 2 to the power network bit is 2 to the power 2 is 4. Whatever the number of subnet per network is 2 to the power host bit minus 2. One for network ID and one for broadcast ID. So what is 2 to the power host bit? 2 to the power 6 minus 2 gives you 2 to 4 to 8 to 16, 30 to 64 minus 2 is your 62. So that means I should have 4 network. In each network I should have 62. This is your subnetting. Now what you do, you calculate a block size. So what is block size? 256 minus this thing. Now what you did is you converted this thing here into, so this was your subnet mask, right? And now you converted that into customized subnet mask, because what you did is you convert two zeros into ones. Now I'll show you. I'll just give it very quick. 1 2 1 2 3 4 5 6. So what I do is I'll write 1 2 4 8 16 32 64 128. Now I'm writing at the top, 1 2 2 4 4 4 8 16. I'm just doubling them. Whatever has 0, I don't need this. It has a 0, I don't need those zeros. But whatever has a 1, I'm going to add those numbers. So 128 plus 64 gives me 192. That's how I got 192. Now I'm just subtracting that 192 from 256. That gives me a block size. Why I need a block size? So I will start with 0. I will add 64 plus 64. 64 plus 64 gives me 128. Plus 64 gives me 192. Plus 64, I have to go till 256. I have to start with 0 and go till 256 and add that number, which is the block size. Now if this is the 64, so 1 before 64 is 63. That's how I get this last number. So if this is 128, the last number before 120 is 127. So if it is 192, the number before that is 191. Sorry, this is not 191, this is 191, right? Number before this. And if it's 256, this should be 255, right? So I will not take this because I will not go beyond 256. Now what I will do is, this is the 0, the first number starts with 1, it goes till 62 because last one is 63. Same goes here, it's 64 and the one is 65, 66, 68, 797. I'll go till 126 because last number is 127. This also 128. Okay, so how many now? How many I have here? 1 2 3 4. So how many subnets I have? 4. And in each subnet I have 1 till 62 means 62. In each subnet I have 62 hosts. Now I got an example here, right? So if I want to use the first one, how I use it? So I'll just give you an example here. Now first one which I have is, I'll just take the first 3, 192.168.3 dot. I'll go with the last one, okay, dot 0. And the first one would be 192.168.3.1. It will go till 192.168.3.62, and the last one is 192.168.3.63. So what does that mean? That means you can use any IP address from 33.1 till 6.6 till 3.62. This is your network ID and this is your broadcast ID. This is why I did -2. Alright, so this is your subnetting. And if you understand the concept, then you do subnetting in head. then you'll be able to solve a lot of questions. But first you need to understand how you do subnetting, then you do subnetting in head. There are a lot of ways of doing subnetting, but I've shown the quickest way. Lesson 5. When the destination IPv4 address is on a different IP network or subnet, the host forward the packet to the default gateway. We understood that. SAM network, give it to switch. Different network, give it to router, which is your default gateway. ARP is your address resolution protocol. It's going to resolve an IP address to a hardware address. Yes, there was a question on this concept. Unicast is sending packet to a single recipient. Broadcast is one-to-all communication. Multicast is one-to a group communication using IGMP. Anycast is one-to-closest communication, may be used in load balancing and failover, which we have in IPv6, right? New concept. A public IP can establish a connection with other public network. Please remember these private IP addresses 10 dot anything. So this is the actual range, class B and class C. APIPA is your automatic private IP address in this range. So if you this is also what we call link local. Microsoft calls it APIPA, but the actual IEEE calls it link local address because it's being used in IPv6 also. So what's APIPA? For example, you are connecting with a DHCP. DHCP is not able to give an IP address, so it gives you IP in this range 169.254. Okay, dot anything. So this is what we call APIPA. So systems can at least connect with each other, but they will not be able to connect through the router outside. Loopback address is 127.0.0.1, but this is the actual range to test yourself. 0.0.0.0.0/8 is used with a specific when a specific address is unknown, may be used as a source address by a client seeking DHCP lease. 6. So please remember this command, NetSH interface IP set address. This is how you set an IP address, which is your dynamic. For static, you can use this command. Or NetSH interface IP show config. You can test that in PowerShell. In your system, and PowerShell you can also use these commands. ARP cache show cache IP neighbor in Linux. There was a question on this concept. ARP-S IP address MAC address add to add the entry, and ARP-D to delete the entry. Please remember how you can use IP config to check the IP address if you want other details, IP, MAC, and all that. If you want to release IP from a PC, if you want to renew that, if you want to display the DNS, you want to flash the DNS cache, or you want to register the DNS if it supports dynamic update. So please remember those commands. Fconfig for Linux and IPA for Linux flavors. Ping utility sends ICMP request packet to a destination host. ICMP is used to report errors and send message about the delivery of a packet for unicast traffic. You can use 4 or 6 for IPv4 or IPv6, and you can use this T switch to ping continuously. So what are the ping error message? Destination host unreachable, no routing information, maybe incorrect default gateway, or maybe loss of connectivity with a router, or router configuration error. If there's a no reply, request timeout, that means host is unavailable, it cannot route reply, etc. So what are the common issues we have? Power issues, maybe we need to check if we have a stable power. UPS may be needed. For hardware failure, we need to check switch, routers, modems, cabling. If there's a hardware failure, we need to find what's the nature of the problem. Resetting may help, or restart your network devices. You can also check the the LED status, which we have seen, and you can also use switch CLI to check those commands. IP config issue, check if the incorrect IP is assigned or incorrect subnet mask. For duplicate IP and MAC, Windows will display warning and disable IP. For Linux, doesn't check for duplicate IP. You can use ARPing-D on Linux to detect duplicate. Here you have some scripts and all that, or duplicate address detector. Problem using Wireshark. Problem isolation. So first you ping your loopback, then you ping your host, then you ping your default gateway, then you ping your host, then you ping IP and the host name. This is how you fix the problem. For incorrect DNS issue, if you can ping by IP but not by the host name, there can be a DNS issue because your system is not able to do mapping of domain with IP. So this is your IPv6 128-bit. There's a in IPv6 you have a traffic class for priority. It also uses flow label for quality of service. It also has a payload length. Jumbo payload is up to 4 GB. So in IPv4 we have only 9000. Here we have 4 GB. It also has next header. Hop limit is replaced by TTL. So in IPv4 we have hop limit. Here it's replaced by TTL. So this is an example of IPv6 128-bit. There's no broadcast in IPv6. It's being replaced by multicast. This is an example, right? No global routing, 3-bit here, network bit here, and here you can also do subnetting with 16th bit. So this is your global unicast. It starts with this. So this is how you get EUI64 from the MAC address. You get this is how you get IPv6 from MAC. So if your MAC address is this, what it's going to do, it's going to insert FFF0 in middle, and the last bit it is just going to convert this C. So what is C? 0012. So how it converts this? Let's see. 1 2 3 4 5 6 0 0. So what you do, 1 2 4 8, here also 1 2 4 8, because these are two parts. So 8 plus 4 12 13 14 15. This becomes 15 and this becomes 8 4 12. But in hexadecimal, what we do, for A is being replaced by 10, because 9, then you have 10. B is being replaced by 11, and C is being replaced by 12. D is 13, E is 14, and F is 15, right? So what you do here, this is going to be your F, and 12 is going to be replaced to your A, B, 10, 11, A, B, C, right? So this is what it was, right? But what they did is they convert, if it is 0 convert to 1, if it is 1 convert to 0. Okay, so this is your FC. Now what about this? This is your F, but whatever the other part, now what it has become, 1 1 1 0. So 1 2 4 8, 8 plus 4 12 13 14. Now it has become 14, so 14 is your E, right? It became FE. So this is how they convert. Please remember these other addresses. This is your link local address, like APIPA. So IPv6 host is always configured with a local address. It is appended with 0 index scope ID. %1 is for Windows, and %Ethernet 0 is for Linux. Address auto configuration and automatic name resolution is also known as a 0 configuration, 0con. Alright, in IPv6 you also have a neighbor discovery ND protocol. It does some function that ARP and ICMP does in IPv4. There's address auto configuration. It enables the host to configure IPv6 address automatically, detect if it is in use on a local network, and use NS and NA, network solicitation and network advertisement. Prefix discovery enable host to discover new network prefix that has been allocated to a local subnet. There's also local address resolution. It allows the host to discover neighbors. Redirection enable a router to inform host of a better route to a particular destination. Slack is stateless. There was a question on Slack. Address it is mentioned in which the host or router interface is assigned a 64-bit prefix, and then the last 64 bits of its address are derived by the host or router with the help of the process which we discussed, EU64. ICMPv6 is for error messaging and informational messaging. Under IPv6, routers are no longer responsible for packet fragmentation or reassembly. So that's why they use MTU in that. IPv6 replaces ARP with ND, network discovery. Multicast address has this prefix, and multicast link local has this. Dual stack is host and routers can run both IPv4 and IPv6. Tunneling can be used to deliver IPv6 packet inserted into IPv4. Microsoft provides support for tunneling using Terado over port 3544. This is unspecified and this is a loopback. Please remember that in IPv4, IPv6. Okay, let's go with 7. So the IP network or subnet for each active router interface is automatically added to a router table known as directly connected route. A state route is manually added to routing table and only changed if edited by the admin. Default route defines next hop router for a destination that cannot be matched by another routing table entry. This is also what we call gateway of last resort. IPv6 doesn't allow router to do fragmentation. Instead, the host does MTU discovery to work out the MTU supported by each hop and crafts IP datagram that will fit the smallest MTU, right? Very important. A black hole means that a packet is discarded without notification back to the source. A network where all routers share the same topology is described as steady state. A flapping interface is one that frequently changes from online to offline and offline to online. Autonomous system is a network under administrative control of a single owner. RIP is your routing information protocol. It's a distance vector protocol. Select path with less hop count. RIP sends entire routing table as update after every 30 seconds and a minimum hop count is 15. Version 1 supports classful addressing, uses broadcast to send updates for UDP port 520. RIP version 2 supports classless addressing, uses multicast over UDP 520, supports authentication. RIP next generation is for IPv6 and uses UDP port 521. There's a question on OSPF, not RIP. There's a question on OSPF. EIGRP uses bandwidth and delay as metric, sends update when there is a topology change, it sends hello message. It is encapsulated directly in IP datagram. OSPF is a link state protocol, hierarchical. It divides all the networking space into areas. With area border router connect multiple areas. There's an area 0 which is a backbone area. Neighbors share link state advertisement updates to build link state database. It requires more CPU and memory. It supports plain text or authentication. BGP does routing between ISPs. Path selection is based on multiple metric like hop count. Weight, it uses weights and local preference. Origin, community. So these are some terms. There was a question on BGP also. This is a path vector, works over TCP port 179. Administrative distance is used to express trustworthiness of a route. Directly connected has an administrative distance of 0. Static route has AD of 1. BGP has 20. EIGRP has 90. OSPF has 110. RIP has 120 and unknown has 254. So this is where the router gives a preference to a route based on its AD. CIDR address looks like a normal IP address except that it ends with a slash followed by a number. The number of the slash represents the number of address in the range. VLSM stands for a variable length subnet mask, where the subnet design uses more than one mask in same network, which means more than one mask is used for different subnets of a single class or a network. It is used to increase the usability of a subnet as they can be of any variable size. Edge router placed at a network perimeter with external and internal interfaces. Customer edge, it's also what we call provider edge. Internal routers have no public interface at layer 3 switching. This is also very important. A layer 3 switch is optimized for routing between VLANs. Asymmetric routing refers to a topology where the return path is different to the forward path. So module 8, topology. So in a client server, some nodes like laptops act as client and servers are powerful centralized resources. In peer-to-peer network, each system can act as both a client or server. Size of a network is the number of nodes and scope area over which nodes are distributed. Size of a network is a number of nodes and scope is the area over which those nodes are distributed. Data center is only going to host server and storage mostly. It doesn't have those end systems, right? Different topologies. Physical topology is the placement of nodes and how they are connected. Logical topology is the flow of data through the network. In point-to-point link, single link is connected between two nodes. In a star topology, each node is connected to a central node, most widely used. And there was a question on star topology, easy to reconfigure and troubleshoot, like hub and spoke topology. For mesh, each device has a point-to-point link with every other device, commonly used in WAN. Number of links are calculated using this formula, n into n minus 1 by 2. For example, if you say I have 8 nodes, so 8 into 8 minus 1 is 7 by 2. So 2 ones are 2, 4s are 8, 4 7s are 7, 4s are 28, right? So 28 links. In a ring topology, each node is connected to other node in a closed loop. Each node can regenerate transmission. In a bus topology, each node connects to a MAN cable using tap. It is shared access topology. Bus is terminated at both ends. Hybrid uses a mix of other topologies. Now this is very important. Most widely used topology. Star of star topology, also known as snowflake topology. Cisco designed for a three-tiered hierarchy. Cisco is going to divide all the devices into three layers: core, distribution, and access. Access or edge layer is for end users. Distribution layer provides fault tolerance, is used to implement traffic policies, routing boundaries, filtering quality of service. Layer 3 switch works on the principle of route once, switch many. Layer 3 switch uses ASIC, application specific integrated circuit. Layer 3 switch cannot usually do WAN routing and often supports Ethernet only. Core layer is highly available backbone. STP is your spanning tree protocol. Switches are going to organize into hierarchy. There's a root which is at the top. Switch with the lowest ID. There's a question on how you choose your root. So remember this. Switch with the lowest ID becomes the root, comprising priority value and MAC. At the top root ports, there's a designated port and there's a blocking port. Broadcast term causes network utilization near maximum capacity. CPU utilization up to 80% or more, switch becomes unstable. So this is your root bridge, and root has some so the other bridges which are at the down level, they will choose this is going to be my root bridge, this is going to be a root bridge, this is the root, it has a designated port, and there could be a blocking port because it can make a loop. If this guy needs to send a data to this, there are two ways: either go through this way, go through this way. It can make a loop, so that's why they block this, to prevent those loops. Alright, managed switch allows configuration of VLANs to isolate ports to separate broadcast domain. VLAN with ID 1 is a default VLAN. VLAN ID can range from 2 to 4094. In 802.1.q or 802.1q, VLAN traffic is recognized by a tag inserted in Ethernet frame between the source address and Ethernet type field. Tag has information about VLAN ID and priority. So yes, there was a question based on this concept. If a frame needs to be sent over a trunk, switch adds 802.1q tag to identify VLAN. Sometimes host attached to a port may be configured to use multiple VLANs and would need to be connected to a trunk port like virtualization host. VoIP transmits voice as a data packet. Switch use voice VLAN to separate PC and VoIP traffic. Let's go to module 9, explaining transport layer protocols. So please remember the port range. These are well-known ports. These are your registered ports. These are your dynamic ports. Port number with a source IP packet is also what we call socket. TCP is a transmission control protocol. It's a credential oriented. It is a guaranteed. It gives the acknowledgement. So this is how three-way handshake is done. Client sends a SYN packet. Server is going to reply with SYN ACK, and this is going to reply with ACK, and connection is established with a three-way handshake. SYN, ACK. Please remember what kind of packets are being shared. UDP is your user datagram protocol. It works at a transport layer. It is connectionless. There's no guarantee. There's no acknowledgement or flow control. It is used by real-time services. It is suitable for applications that send small amount of data in each packet that do not need acknowledgement. For multicast and broadcast traffic, it is used for multicast and broadcast traffic like voice and video. Header is 8 byte compared to 20 byte for TCP. So please remember these ports. 514 is for syslog, 546 is for DHCP v6 client, 547 is for DHCP v6 server, 57 is for SMTPS. So based on the port, they are trying to identify which port we should not use. 636 for LDApp secure, 993 is for IMAP, 995 is for POP, 14 POP secure, 1433 is for SQL server, 3306 for MySQL, 3389 for RDP, 5004 for RDP, and 50. So there was a question where they mentioned a lot of ports, and we needed to choose what are the secure ports, so which one we should not use. So you have to choose one insecure port out of that. So these are the ports. 20 is for FTP data, 21 for FTP control, 23 for telnet, and yes, remember this, very important, 25 for SMTP, 53 for DNS, TFTP for 69 port is for TFTP, which is not secure, and 80 is for HTTP, 110 is for POP, and 137 is for NBNS, 143 is for IMAP4, and 161 was for SNMP. So please remember these important ports. IP scanner. Alright, so IP scanner is a tool which does host discovery. Is going to discover topology, like the examples we have Nmap, Angry IP, or PRTG. Nmap is a security scanner. It is used for IP scanning, auditing, pen testing, open source GUI. So there was a question on this concept. Please remember this. NetState, check port status on local host or active TCP connection. Local and foreign addresses and ports is going to detect that. Based on this also there was a question. These are the different types of scans. SYNSCAN, this is a half open scan. You are not completing three-way handshake. Here you do a three-way handshake. Full TCP scan, it's less stealthy. And this is your UDP scan. It takes long time. There are no acknowledgement. For port scan, you are going to use -p. By default, Nmap is going to scan 1000 ports. And this is for service discovery or fingerprinting, SV or A, using script. So what A does, A is going to use a script. A is just going to use a trace route. It is going to use operating system, find the operating system and the version of operating system. Lesson 10, explaining networking service. So DHCP is your dynamic host configuration protocol. Automatically IP address is assigned to the PC with some optional parameters. So first your PC is going to discover a DHCP server. This is what we call discovery. In the offer, it is going to give it all the settings like IP address and all that. So DHCP server sends offer to the client. Client is going to accept that offer with the IP address and the acknowledgement. So DHCP server is assigning IP to the client and send the acknowledgement. So this is what we call DORA process: discover, offer, request, acknowledgement. Please remember, this is going to be a broadcast. Reply is going to be a unicast. This is going to be a broadcast. Reply is going to be a unicast. In some books they will say a lot of there is a confusion, but that is the right way: broadcast, unicast, broadcast, unicast. DORA, discover, offer, request, acknowledgement. Discovering for the DHCP server, getting offer with the IP address, and then requesting the server, please give me some other settings. Server will remember it with the acknowledgement. Okay, I'll give you this IP for those many days. Lease, there's a DHCP pool, there's a DHCP starvation attack, exhaustion attack. So we'll understand those. Scope is a range of IP addresses for a single subnet. No scope can be applied to more than one subnet, and no subnet can contain more than one scope. So there's a relay agents or IP helper for request to a central DHCP server. Reservation is mapping MAC address to specific IP from pool. DNS does mapping of domain name with IP. There are 13 DNS root servers. There are top level domains. DNS is operated by ICANN. There are two types of lookup. One is your iterative lookup. It's a name server responding to a query with either the requested record or the authoritative serial address. Recursive, it queries the other server until it finds the requested record or times out. SOA, it's a startup authority. It identifies the primary authoritative name server. Name server identifies the authoritative DNS name server for the zone. Address record resolve host name to IP. Canonical name is your LS record. So please remember, there was a question on this also, canonical name. Round robin DNS can have multiple records with same host name but different IP addresses. MX record is a mail exchange used to identify an email server for domain. MX record must not point to a canonical name. SRV record is a service record, contains server, service name and port on which a particular application is hosted. It may be to locate a VoIP or media service. Please remember, there was a question on this record also. SPF is your sender policy framework. IPS or name server that are permitted to send email from a particular domain to prevent sending spam. DKIM is your domain key identified mail used to decide whether you should allow or receive email from a given source to prevent spam and mail spoofing. Can use encrypted signature. Forward lookup is going to return the IP for the domain, and reverse lookup is going to return domain for the IP. Yeah, because if you give the domain, you get the IP. That's your forward lookup. But if you give the IP, get the domain, that's why you do a reverse lookup with PTR record. DNS listen for queries on port 53. Some DNS servers are configured to allow connections over TCP port 53 for a large record transfer, like IPv6 is deployed, or if using DNSSEC, then you can use TCP protocol. A single zone namespace might host record for multiple domain. A single name server might be configured to manage multiple zone. So there's a primary or master. Earlier we used to call it master, which by records are editable. In the secondary or slave, the server has a read-only copy, which is maintained through zone transfer. A name server that holds complete record for a domain is what we call authoritative. Both primary and secondary are authoritative. Servers that do not maintain zone or known as cache-only server. Non-authoritative answer is from a cache record. You might have seen when you get a reply from non-authoritative, that's your cache record. Internal DNS is used in a private network. External DNS can be accessed by internet clients. NSLOOKUP is used to troubleshoot DNS. DIG is your domain information grouper. It's a CLI tool for doing the same. Lesson 11 is on expanding network applications. HTTP is your hypertext transfer protocol. Client request resource from server using URL. Request and response are defined in a header. Payload is going to serve the web page, how the page should be formatted. There's also HTTP version 2, which uses binary data delivery rather than plain text. HTTP is a stateless protocol. Server is not required to preserve information about the client during a session. Man web server platforms are Apache, ISR, Nginx, or they call it Nginx, or yeah, I guess. SLTLS works at the session layer. Ninjix or Nginx, I'm not sure what they pronounce. Different countries, right? Different ways. In active FTP, client chooses port number. Server is going to open data connection on a chosen port. But in a passive FTP, server is going to open a random port and then send it to the client. So if a client is going to choose a port, that is your active. If a server is going to choose a port, that is your passive. Please remember this. TFTP is your, so if I mention please remember this, now please understand that's very important. TFTP is your travel file transfer protocol. Connectionless, it uses UDP port 69. No guarantee. Small file transfer, it supports only read and write file. No browsing or deletion, and no security. SFTP is your secure FTP using SSH. FTPS is also secure with SSL or TLS. SMB is your server message block or Windows network. On a Windows network, you use this port. It provides file or print sharing. It uses port 139 on a legacy and 445 port on new software. SMB version 3 is supports message encryption. Port 9100 is a standard TCP/IP port. It's also called AppSocket or JetDirect. Internet Printing Protocol uses TCP port 631. Please remember ports. Oracle uses this port. Microsoft SQL Server uses this port. MySQL uses this. PostgreSQL uses this. SMTP secure version uses 587. IMAP secure, please remember this. And POP secure uses 995. So a PBX, private branch exchange, is automated switchboard providing a single connection point for voice line. SIP is your session initiation protocol, most widely used session control protocol. UDP TCP 5060 the port number, but actually delivery is done by some other protocols like RTP. In Windows, you have MAPI, Message Application Programming Interface, which is used to access Exchange mailbox using HTTPS. Voice Gateway is a measure of translating between VoIP system and a legacy voice equipment. For module 12, SSH for secure remote access, it uses TCP port 22. It uses a public-private key pair known as host key. Telnet is both a protocol and terminal emulation software, port TCP 25. RDP is your remote GUI, TCP port 3389. So there was a question based on this logic. NTP does synchronization of time-dependent application over UDP port 123. Public NTP servers, these are some public NTP servers: time.google.com, windows.com, Apple, NIST. Environment sensor is used to detect factors that could threaten the integrity or availability of an application or its function. SNMP is your simple network management protocol. It uses agents to, so agents which are used, they maintain MIB, management information base, device query over UDP port 161, and traps are being sent on 162. Which is, there's two ways, like, if a manager is going to check the status, or the hosts, those agents are going to send their status to the manager using trap. So please remember these logs: system and application log. So here you have system log record startup events plus subsequent change to configuration at OS level. Application log record data for a specific service. Audit log is going to record use of authentication and authorization privilege. If there's any successful or fail events, which are also known as access or security log. Performance or traffic log, record status for compute, network, storage, resources over a defined period. Syslog is for log collection. It's a de facto standard for logging events from distributed systems. It uses UDP port 514. Please remember this port. Syslog security level. So 0 is for emergency on a syslog severity level. 1 is for alert, 2 is for critical, 3 is an error, 4 is warning, 5 is notice, 6 is informational, and 7 is debugging. Bandwidth is a mode of information that can be transmitted in BPS. Latency is time it takes for a transmission to reach recipient in milliseconds. Jitter is your variation in delay in milliseconds. Differentiated services is what we refer by diffserv. Classifies each packet passing through a device. It's a layer 3 service tagging mechanism. Similar service at layer 2 is 802.1p. Traffic shapers delay certain packet types and other packets have higher priority. Network throughput can be measured with these tools like iperf, TTCP, and BWPing. Top talkers or interfaces which are generating most outgoing traffic. Top listeners receive most incoming traffic. 13 on security. Please remember integrity, and there was a question on integrity. So confidentiality, authorized access. Integrity deals with authorized modification. Availability, it should be available to authorized users. So in security, you need to ensure CIA. Vulnerability is a weakness. Please remember this also. Threat, the potential for someone to exploit the vulnerability and breach security. Risk is the likelihood and impact of a threat actor exercising a vulnerability. The overall status of a risk management is known as a risk posture. Risk posture shows which risk response options can be identified and prioritized. Posture assessment is often done with reference to security framework. Mission essential function is one that cannot be deferred. These functions must be restored first if there's a service disruption. So there's a order of restoration where we define what needs to be restored first. BIA, which is a business impact analysis, and so it just identifies the risk, where BCP identifies the controls. An exploit is a specific code or method of using vulnerability. A vulnerability that's exploited before the developer knows about it or can release a patch is what we call a zero-day vulnerability. Vulnerability assessment is the evaluation of a system security and ability to meet compliance requirement based on configuration state of the system. CVE is our common vulnerability and exposure. It's a dictionary of vulnerabilities. Please remember this, also very important. Threat assessment is identifying threat source, profiling types and capabilities of a threat actor. There are external threats and there are also internal threats within the organization. So SIEM is your security information and event management. Automated collection, it does aggregation and analysis of log data. Pen testing is how exposed the organization is to vulnerability that could be exploited by threat actors. So it is an intrusive assessment technique. This extra intrusive, like putting stress on your servers. Privilege access management refers to policies, procedures, and technical controls to prevent the malicious abuse of privilege accounts. Least privilege, RBAC, and zero trust are a part of PAM. So there's a PIM, there's also PAM. Privilege identity management, privilege access management. There was a question based on this concept also. Vendor management is selecting a supplier companies and checking the risk inherent in relying on a third-party service where you do the evaluation and all. So please remember identity and access management, where you do identification, you create an account. In authentication, you just validate the identity. In authorization, you check what rights does the authenticated user have, and in accounting, you track the usage, what user does. MFA is your multi-factor authentication. You can use more than one factor. So you can use a knowledge factor, something you know, like PIN or password. Ownership factor, something you have, like a phone where we can send a code. Human or biometric, something you are, like your iris scan, retina scan, and all. Behavioral factor, something you do, like the way you walk and the way you type and all. Location factor, somewhere you are based on your IP address or geolocation. Radius is your remote authentication dial-in user service for client device accessing or switch, wireless and VPN. Microsoft has a similar service which we call NPS Network Policy Server. I think it's not being used, but there's a similar service. Radius uses this port. Please remember there was a question on TACACS. It's a terminal access controller, access control system, more reliable, flexible. It is developed by Cisco. It is authenticated administrative access to routers and switches. It uses TCP port 49. LDAP is your lightweight direct access protocol. It uses port 636. So I think this video can go for 2 hours. I just try to make it a little short, so I think it can go for 2 hours, but this is just one video we need to cover before you plan for your exam. So lesson 14 is troubleshooting supporting secure networks. I'm not going in detail. I'm just giving an overview of what you need to remember. So if you have already gone through the book, if you have just gone through the labs, if you've done practice questions, then you just go through this video series to see what you need to remember, or just try to see if you know these things. Network segmentation is dividing clearly defined areas using VLAN and subnet. Zone is an area of network where security configuration is same for all hosts within it. Screen subnet or DMZ uses 2 firewalls placed on either side of a perimeter network zone. Edge firewall is also known as screen firewall, and internal firewall is also known as choke firewall. Perimeter network can also be designed using triple home firewall. One leg goes to your internet, one goes to your office intranet, and one goes to your DMZ. Firewall does traffic filtering. There's a packet filtering firewall. There's also a stateful which operates at layer 5. That's what I mentioned. If they say in a question a particular firewall, then you can just see where it works, because there are different types of firewalls. Stateful operates at layer 5. There's also a stateless firewall. What a proxy server does, it just that's why proxies are slow, because what they do, a proxy is going to deconstruct each packet. It does a packet analysis. It is going to rebuild the packet and forward it if it conforms to the rule. Forward proxy is for protocol specific outbound traffic, and reverse proxy is for inbound. Non-transparent proxy, in which client is configured with a proxy server address and port number, and a transparent where configuration is not needed. So there's a difference between transparent and non-transparent. NAT is your network address translation, mapping private address with public address. PAT is your port address translation, where multiple private IPs map to a single public IP using port number. Defense in depth uses multiple security layers. NAC is your network access control for authenticating endpoints when connecting to a switch port or wireless or VPN, and uses 8.2.1x port security, EAP and AAA. Honeypot is a computer setup. So very important. There was a question based on this concept to attract attackers, analyzing attack strategies and tools. It provides early attack warning, or you can also divert traffic from actual system. Separation of duty is dividing duties and responsibilities among individuals to prevent abuse of power. IDS is your intrusion detection system. It's a real-time analysis of network traffic or system and application log configured with signature pattern. IPS provides active response to a network threat, that is, it detects like shunning is to block an IP address. So if you block an IP address, that's what you call shunning. Please remember these important points. DHCP issues could be like a PIPA. There could be a scope exhaustion. Attacker can generate some fake tool to kind of send fake request. NAM resolution issues, check your local cache, check your host file, query the DNS or DNS configuration issues. For the VLAN assignment, check the DHCP or DNS are available to VLAN. Check if there's a proper routing for VLAN to VLAN communication. Check DHCP relay, is it set up properly, and check if IP configuration is set up. Other issues could be unresponsive service, network performance misconfigured, firewall or ACL, untrusted certificates, NTP issues, BOD challenge, and license issues. Alright, module 15 is deploying and troubleshooting wireless networks. So IEEE 802.11 standard is for wireless. It uses CSMAC. This is not the collision detection, this is collision avoidance. So please remember this concept. There was a question based on this. 2.5 propagates through solid surface, long signal range, no support for high number of individual channels, and it's often congested. There's a risk of interference. Data rate is lower than 5G. 5G, it is less effective in penetrating solid surfaces, no maximum range compared to 2.5, but it supports more individual channels. It has less interference and supports high data rate. So there was a question based on this logic. Please remember these standards: 802.11a, B, G, N, AC, and AX. So there was a question on this kind of table which I have. Like, we need to remember those standards. A was designed in 99. It works in 5 gigahertz with 54 speed. B 1999 2.4 and 11. G 2003 2.4 with 54 Mbps. N 2009 with this speed and 600 Mbps. AC 2014 with works in both the channels with this speed. AX is the latest one, 2.4. It was designed, as per my knowledge, I guess, or as per the documentation, this is the latest version. Please remember that this is the latest version. So there was a question on this. 802.11n uses MIMO, which is multi-input, multi-output. This is also what we call Wi-Fi 4. Wi-Fi 5, AC is also known as Wi-Fi 5, and AX is also known as Wi-Fi 6. This is to support IoT. Wireless infrastructure topology uses access point. This is also known as BSS. MAC address of AP is known as BSS ID. Connecting BSS together makes ESS. So please remember, there was a question on this. There was a question on this also. SSID is your service set identifier. It's the name of access point. Not on this. There was a question on this. IBSS. So SS heat map shows areas where strong signal is green and yellow, and warning signal is in orange, and red is with a signal drop. Thin AP needs wireless LAN controller to function, but fat AP doesn't need wireless controller. Ad hoc is what we call IBSS, independent basic service set. It doesn't have access point. Wireless mesh network is 802.11s, mainly for IoT. The RSSI is receive signal strength indicator. So please remember, is the strength of the signal from transmitter at the client end. Value of 0 is better performance, like 65 dB is a good signal, but over 85 is packet loss or drop. RSSI and SNR can be measured using a Wi-Fi analyzer. There's also effective isotropic radiated power. Please remember these two terms, and you can solve 1 or 2 questions. This is the sum of transmitted power, antenna cable connector loss, and antenna gain. CCI is your co-channel interference. It uses a concept, we have seen contention, where multiple APs use the same channel, or adjacent channel interference, where APs are configured to use different but overlapping channels. Like, you always remember 1, 6, 11 or non-overlapping. EMI can be detected using spectrum analysis. So channel 1, 6 and 9 are non-overlapping. Always prefer these 3 channels. WPA is your Wi-Fi protected access using TKIP. WPA2 uses AES replaces RC4 with CCMP replacing TKIP. In WPA2, PSK uses a passphrase to generate key used to encrypt communication, also known as group authentication. In WPA3, the SAE, which is simultaneous authentication of equal, is used. So client or access point can use disassociation or deauthentication frame to notify the other party that it has ended the connection. So attackers use these techniques. Open authentication is client is not required to authenticate. So let's go model 16, comparing WAN links and remote access methods. The service related entry point at which access provider's network terminates is also called a demarcation, or a minimum point of entry. Minimum point of entry. T-carrier. So what is T-carrier? Developed by Bell Lab to allow multiple calls to be placed on a single cable. T1 line has 24 channels with 1.544 Mbps, terminated with smart jack having RJ48C or RJ48X. DSL is your digital subscriber line to transfer data over telephone lines, known as local loop. Symmetric is having same download and upload, but asymmetric has a fast download but slow upload. Fiber to curb, fiber to premise, or fiber to home is where you might see the fiber getting connected to your home. PPP is your point to point, is an encapsulation layer 2 protocol. It encapsulates IP packets and transmit over digital line. There's no security. GRE is your generic routing encapsulation layer 3 protocol, and no mechanism for authenticating users or devices in GRE. We need to use a different protocol for security. There are two types of VPNs, site to site and remote site. So please remember, there was a question on this concept. So remote to site, if you want to connect using your PC, you use remote to site. If you want to connect to branch, you use site to site. Split tunnel, there was a question on this also. Split tunnel where client access the internet directly using its native IP and DNS. Full tunnel where internet access is mediated by a corporate network which alters client IP and DNS and may use proxy. So please remember these two tunnels. AH, authentication header in IPsec does not hash on a whole packet, including header plus shared secret key. Payload is not encrypted. No confidentiality, but ESP, which is encapsulating security payload, provides confidentiality, authentication, and integrity. IKE is your internet key exchange. It handles authentication and key exchange, referred to as security association. Transport mode of IPsec is used to secure communication between hosts on a private network. Tunnel mode is used for communication between VPN gateways across unsecure network, also known as a router implementation, where both header and payload is encrypted. So it's a secure one. Alright, is explaining organizational and physical security concepts. So I'm just going continuously. It has been 1 hour 45 minutes, I guess. I think it can go for 2 hours or a few minutes. Configuration management is identifying and documenting all infrastructure and device installed at a site. Change management is implement a change in plan and controlled way. So please understand, you are going to solve 1 or 2 questions based on this concept. SOP is sets out principal goals and consideration like budget security for performing a task and identify line of responsibility and authorization for doing it. Audit report focus on identifying and recording assets. Incident response plan is set out the procedure, tools and methods of communication and guidelines for dealing with security incident. Disaster recovery plan is to address large scale incident. Business continuity plan enable the organization to maintain normal business operation in the face of some adverse event. So please remember what is the use of those different plans. Onboarding is welcoming new employees, doing the background check, giving them identity and access, asset allocation and training and policies. Offboarding is to ensure employee leave company gracefully. You disable the IAM, you retrieve the company assets, so they return the personal assets. Usage policies, you need to set up some password policies. Acceptable use policy, so what they are accepted to do. Bring your own device policies, remote access policies. DLP is your data loss. It's actually data leakage prevention, because data loss means when someone steals your original copy, but leakage when sensitive copy goes out. I don't know why they say data loss prevention. It should be actually data leakage prevention, but some books you can find it data leakage prevention. To prevent sensitive data from going out. SLA is your service level agreement, setting out detailed terms under which an ongoing service is provided. So very important concept, please remember, this will be helpful in your exam. NDA define what is the use of sensitive data is permitted. MOU is to express an intent to work together. So NDA is also important, please remember. Access control hardware, you can use a badge reader, biometric access control vestibule. Physical security for servers, you can just lock racks, you can use locking cabinets or smart lockers. Detection based devices, you can use cameras or asset tags. And alarm and tamper detection, you can use circuit based or motion detection. For asset disposal, make it sure you do a factory reset, you destroy media, you sanitize it properly. For example, SATA and serial attached SCSI, it uses secure erase command, or in instant secure erase ISE, when erase command is issued, media encryption key is also erased. Make it sure you train your employees. So awareness is very important. IoT is a global network of personal devices with sensors to pass data between themselves. This is what we call machine-to-machine communication. Physical access control system is a network of monitored locks, alarms, and CCTV. ICS is your industrial control system used in critical infrastructure like power supplier, water supplier, health, telecommunications, and a national security service. A cable network for industrial application is also what we call operational technology. So 18, 19, 23 to go. Disaster recovery and high availability. Please remember those terms. RTO is your recovery time object, is a period following a disaster that an individual IT system may remain offline. WRT is your work recovery time, time for additional work after the system recovery, like restore backup, you do the test functionality. So RTO plus WRT should be less than your MTD, less than or equal to, but always less than. That means before you go to MTD, because that's your maximum time. So till then you should have done your RTO and WRT. MT, yes, there was a question based on these three terms. MTB, mean time between failure. This is the expected lifetime of a product. So I think I choose the wrong answer here. So there was a question based on this. Okay, mean time to failure. This is MTTF. MTTR is mean time to repair, time taken to correct the fault. So recovery sites, you have hot, warm, and cold. So hot site is someone which is running in parallel. So please remember that. If you have limited time, go for hot. If you have a little bit time, like few days, go for warm. If you have 1 month to return back to business, just go for cold site. So you can save a lot of money. There was a question based on this cold site. Multipathing, sorry, I just mentioned this as lesson 2. It's actually lesson 18, so not 2. So this is lesson 80, not 2. Multipathing network node has more than one physical link to another node. Link aggregation or bonding is combining two or more separate cable links between a switch and host into a single logical channel, also known as NIC teaming at a host. So please remember, this concept is known as NIC teaming at a host or port aggregation at a switch, because you're connecting switch with the host. So please remember, this will be very helpful. Load balancer is used to distribute client requests across server nodes in a firm or pool. Clustering is a multipath redundant processing node that share data with another to accept connection. Sharing public IP between two instances in a cluster is a virtual IP or shared or floating IP. Please remember this. And this also. HSRP is a hot standby routing protocol by Cisco to allow multiple physical routers to serve as a single default gateway for a subnet. Last two, applying network hardening techniques. So here we need to remember different types of attacks like footprinting or fingerprinting. So this is also what we call information gathering. Fingerprinting is knowing the operating system, and banner grabbing, we call it banner grabbing when you know the version. Spoofing, you can do MAC spoofing, IP spoofing, or ARP spoofing. So MAC, you can just change the MAC address, you can change the IP address, or you can do ARP, which is a copy mapping of your IP and MAC. So there was a question on ARP cache. You can do a DOS or DDoS attack also, where you send a lot of requests. You can do on-path attack. This is also what we call man-the-middle attack. You sit between two people. Rogue, you can just use a rogue DHCP server or DNS poisoning, where you play around with DNS cache. So in the wireless, you can do the rogue access point. You can use the evil Tiven, which is similar access point, or something looking similar. You can also do deauthentication. You can just deauthenticate any client. You have viruses, you have worms, worm is similar to virus, but it affects your whole network. Trojan is something which looks good but has a bad intention. Potentially unwanted programs, these are also some malwares. Password attacks, whether it's a dictionary attack, whether it's a brute force, is it a hash injections, that can happen using a lot of tools like OPH crack is there, PW dump is there, Medusa is there, HTK Hydra is there. Human and environment attacks could be phishing, where someone sends you an email, you click on it, it takes you a banking website which looks like your bank is asking you to fill the information, but that might be kind of not the right bank. That might be a malicious site. Shoulder stuffing, looking over someone's shoulder to get the password, or tailgating or piggybacking. Guys, please remember the difference. There's a question. Tailgating is like, you are just trying to, you're an employee, authorized employee, okay, and you're just going to inside the organization and you are using your access card, you open the door. So what happens, your door will be open for some time. There's other guy which is just following you, and he's just going to pass the door because you try to open the door, it was open for some time and you just left. There's a guy who is following you and he just tried to enter the door. He doesn't say anything, he's just following you. That's your tailgating. But in piggybacking, he's going to do the same thing, but he's just pretending like, oh shit, can I use your access card? I'm carrying something, or I forget my ID card. So if he says, that's your piggybacking. If he follows, so here he follows and says something. Here he just follows without saying. So that's a difference. Please remember that. Deploying system in a secure configuration is known as hardening. Change default credentials, enforce password complexity length requirements, avoid your common passwords, configure role-based access, disable unneeded network services and insecure protocols. For endpoint security and switch port protection, disable unneeded switch ports. We can also use MAC filtering to configure which MAC can connect to a particular switch. So let's go to last one. Okay, we are I think 154. Just we have 5 minutes. I wanted to make it a little bit like 2 hours is okay. Cloud scalability and elasticity. So different deployment models you have: public, private, hybrid, and community. So there was a question on this also. Please remember, public is when you are not concerned with security, you save money. Private, you are very much concerned, like a bank. Okay, they pay a lot of money, but they need security. Hybrid, you can use both of them. So if you have some part in your premises and some part in your public and private, combination is your hybrid. Community cloud is where 2 or 3 banks can connect together, like they're like two three colleges or universities connecting together is your community cloud. Infrastructure as a service, platform as a service, software as a service, or anything as a service. Depends on what you need. If you need a software, you approach to cloud service provider, they will give you a software. But if you need a platform, so you design your software, you choose PaaS. But if you need an infrastructure as a service, that means you decide your infrastructure. You create your virtual net, you create your subnets, you create your security. So you configure everything. If you are an admin, you go for IaaS. If you are a developer, you go for PaaS. If you are normal organization which needs some software like a end user, you go for SaaS. IAC is also what we call infrastructure as a code. Automation and orchestration. Automation is when you automate something. Orchestration is like it should follow in a sequence, like one automated task, second, third, fourth. These are automated tasks. They should happen in a sequence. That's your orchestration. Hypervisors, please remember type 1 and type 2. This is what we call bare metal. That means you are directly running your virtualization software on the hardware. But here you are going to use some guest operating system like VMware and all that. You have virtual NICs, you have virtual switch. So traffic that goes to and from a data center is known as north-south. For cloud data centers, it's between the server, known as east and west traffic. There was a question on this. Spine and leaf topology provides better support for east-west traffic and uses SDN over. Please remember this also. There was a question on this. Now, okay. Finally, we are done. I just give an overview what you need to remember. I assure you it's going to be very helpful. But I would again suggest go through the official book from CompTIA. This exam is not easy. I have gone through the book. I have done all the labs. I did practice questions. Still, I find it a little difficult. And like at the end, they will just 1 or 2 minutes when I finish this exam. So I spend all the time. I found time management is also very important for this exam. So my technique which I used yesterday, that worked, because what I did is I just tried to go through all the questions. And first what I did is, like I've gone through the book, I've gone through the lab, and I have gone through videos, a lot of videos online. You have a lot of videos online. So I'm not saying like someone is good, someone is bad. Maybe someone likes the way I explain, someone doesn't like. So it's all up to you. Nothing is good and bad. It just depends on what we like and we feel it is good. So nothing is good and bad. If it helps you, it is going to be good for you. It doesn't help, it's okay, no problem, because that's a free. So we're just recording those videos because what I did is I just passed this exam. I was trying to see how it's going to be helpful for others also. What I thought up is, like I did the exam yesterday, so I did a lot of exams. I did 20 global certifications, but what I started with SC900, last one, I started this video. It was very helpful. I got a lot of good response. So I thought of, like if I pass Network Plus, I am going to make a similar video. That's what I did. All the important points which we need to remember. So go through the book, go through the lab. I just did some practice questions online. So you just go for an N10-008 and search for practice questions. You have a lot of sites, like VC Plus is there, IT Exams is there, Exam Dubs is there. A lot of sites are there. But to tell you frankly, I did not see any of the questions. I just saw 1 or 2 questions. I did like 200 practice questions online. I just saw 2 questions coming out of that. So again, do not rely on those practice questions for this exam. Might be working for other exams, but for N10-008, either questions are being changed. I'm not sure what's happened. So I was able to find only 1 or 2 questions. And that's why I did what I did. Like, I thought, like, I can see a lot of questions. Let me solve them first. But what happened is, when I saw question 1, okay, fine, I did it. Second question, okay, it was something new. Those are performance based questions, 2 questions. And then I went through all the questions and I was like, okay, next question might be from questions which I've tried or maybe search online. No, nothing was from them. So what I did is for those questions I felt okay, this could be the answer. I just kept it on review, and I did quick for all 70 questions. I guess, yeah, 70 questions I did the same thing. So I was left with 1 hour. So in first 65, I think there's 165 minutes. So first 45 minutes I did all the questions, and then what I did after that is I tried to see what is the best possible answer for this question based on my knowledge what I had. I removed wrong answers, so I got like 1 or 2 questions which were a little bit confused. So I thought, okay, what will be the best, what will be the best? Okay, this is the best. Okay, let me remove it from review. No, I'm not going to review it, but if I still have a doubt, I'll keep it review. So I still kept 2 or 3 in the review, and at the end I had just 10 minutes. I did it. So I was like kind of a little bit confused because the questions they've been asking was really difficult. Okay, what are the labs? So please explore these labs. You can buy these labs from CompTIA. CompTIA exams are really tough. I did EC Council, I did ISACA, I did Microsoft exams. Microsoft exams are also tough, but CompTIA are really very tough because I did 501 was very difficult, and sorry, I have done 6. Okay, this is not 601. Where I did 601 here. Okay, sorry, this is not 601. I just gave the wrong heading. This is N10-008 and 10-00 because I am just kind of, I did that also. Heading is wrong, but labs are right. I'm going to show you that also. So this is N10-008. Explore the lab environment. You are going to scan and identify network nodes in this lab, and you are going to intercept and interpret network traffic with packet sniffing tools. You are going to analyze results of a credential vulnerability scan. You are going to install, use, and block a malware using backdoor. You are going to do some reconnaissance and scanning. You are going to see how to manage the life cycle of a certificate. You are going to manage certificate with OpenSSL. I just give the wrong lab here. I'll just check it. And manage centralized authentication. In 11, manage access control in Windows Server. Configure a system for auditing policies. Manage access control in Linux, configuring identity and access management, implementing a secure network design, configure a firewall, configure an intrusion detection system, implementing security network addressing. So in short, what I mean to say is that these labs give you a lot of important knowledge which will be helpful in this exam. Okay, so implement, so the other labs which we have here is implement N10-008. So implement endpoint protection, network infrastructure, application attack or browser attack, PowerShell security, malicious code, application attacks, data sources for incident response, mitigation controls, forensics. So 32 labs with a lot of important techniques to understand here, right? So in short, what I would say is just go for N10-008. Okay, just first of all, just go through the book, reference book, get it from CompTIA, and then go purchase also your lab. Do these 2 things, and then also do practice questions online. So I would say if you go through the book, depends on how you read, because it was 600 pages, but actual content is 500. So I just gone through the book in 2 days. I guess I've just read the book in 2 days, like a lot of stuff. Like I just went through book because I had a limited time and I had to pass this exam. So what I did is I just went through the book very quick, like 2 days, like 500 pages was like I just did like there was like maybe 200 pages on a day. I did 250 pages on a day is like a lot of content. I just gone through to extract some important points from the book. But going through book is very important, doing the lab is very important, and then practice questions, and then follow this video, because N10 is being recognized. I keep traveling to different parts of the world and I see there's a lot of demand. Okay, let me use my man camera. So I see there's a lot of demand for Network Plus. So see, there are a lot of certifications, there are a lot of vendors, but it depends on what level you have. If you are starting, I'll say go with CompTIA and go with EC Council. Now if you are at the advanced level, go with ISACA and go with ISCAR. Now what will happen is like ISACA, ISCAR, they also come up with some fundamental certifications, but what I have seen myself is that if you go with CompTIA, just do your A+, Network Plus, Security Plus. These 3 certifications have a lot of demand. everywhere in the world. Now you might also be interested in Pentest Plus, Cloud Plus, Cybersecurity Plus, CYSA Plus, and all that. But I have seen, if I'm being told to choose 3 certifications which have a lot of demand from CompTIA, I'll say go for Network Plus, go for A Plus, go for Security Plus, SY0601 latest version. If it comes to EC Council, again there are a lot of certifications, but the main traffic is there for CHV12, which is the ethical hacking latest version. I did, I think, 9, 10, 11, so latest version which we have 12. So I have done all those from the EC Council. So there's a lot of demand. Others you have like incident handling, you have forensic investigation, you have disaster recovery, you have encryption based certifications, you have CISO at the upper level. But go for ethical hacking or go for incident handling, forensic investigation, they have a lot of demand from EC Council as a beginner level. But when you move advanced, then you have CISA, CISM, CISO, CSSP, which you can do at the advanced level. Might be you are not planning to do all the certifications, but have a path, because for me, anything related to network security and cloud, I'm just doing it because I've just kept myself specific to network security and cloud. That's where I did 20 plus global certifications. Maybe in future I might be planning for CISSP, but what I'm doing is right now I can go for CISSP right now also, but I'm trying to complete all these certifications. So maybe after that I'm planning for A plus, because for CompTIA people go from A plus to Network plus to Security plus. But what I did is I just went from up to top to bottom. People go from bottom up, but I think this technique also works if you go like top to down, like advanced course, then you go to basic courses. You have some kind of confidence. It works well. Now some people they go from basic to top, some go from top to basic. Basic to top, a lot of people do that, but top to basic only few people. It worked for me. I had a confidence. If I do security plus, I can do for network plus. If I do network plus, I can do A plus. I have that confidence in my mind. It might work or might not, but that's other technique. So I would say do these certifications, get certified. I'm also planning to bring up or come up with some other lectures. Please do comment. I was a little bit fast because I wanted to complete that in 2 hours, because that's the time you'll be spending, because that's what I did. When I watch a video, I'll watch like 2 or 3 hours, maximum 4 hours, not more than that, if it is exam special. So that's an exam special for N10-008. This course has a lot of demand throughout the world. Network plus, security plus, ethical hacking, they have a lot of demand, right? So I'll see you in some other lecture, and thanks a lot. I'm going to stop this recording here. We had an overview on Network Plus from CompTIA, and again, please go through the book, go through the lab, go through practice questions, and you can also find there's a lot of discount on CompTIA. I am not asking you to go to my link so I get some benefit. What I'm doing here is just whatever way you have, whatever technique you use, just do it. If it's going to benefit you, I'm happy. Okay, so maybe not now, maybe in future it might be helpful for me, but this video I'm just recording so you guys have an overview of this N10-008. I did it yesterday. I wanted to do something good, so that's why I recorded video. Thank you. Thanks a lot. See you in some other video.